Hi, it's Mrs. Moss here. We're going to continue talking about the way we interpret geological history. Last screencast, we learned about the different processes that can change the age of the rock or affect the order in which the rock layers are formed and deposited. Today we're going to talk about erosion. Now, erosion causes gaps in the geological record. It almost erases layers and literally will take away a rock layer, like ripping out a page in a history book. When a new layer of rock is laid down on a surface left by erosion, it forms a buried erosional surface called an unconformity. Let's look at a diagram to show a visual of the unconformity. In these two diagrams, when we compare the one on the left with the one on the right, we see that the one over here has a squiggly line where the layer 3 used to be. This indicates that the erosion process has wiped away layer 3. So a wavy line represents erosion, or we could also say it represents an unconformity. Let's look at these two diagrams. In diagram 1, we see the deposition occurring of sedimentary rock A, B, and C. I know it's deposition, of course, because it tells me that on the bottom, but I also know it's deposition because it's submerged underwater. The one next to it in number 2, that water, the layers A, B, and C have undergone uplift and have come out from under the water. And actually, a new rock layer at the bottom has appeared or emerged due to this uplifting. I'm going to take this same diagram number 2 and compare it to the next step, which would be step 3, in which case, if you notice what's occurring in 3, the rain has caused layer C to become eroded. So now C is missing, and you can see the shape of the layer B has slight bend or wave to it. That's due to erosion. And layer C, as I said, is completely missing. Now, if we compare if we compare number 3 to a new diagram at number 4, what you notice is water has again moved into this area. Could be from over flooding of a stream and causing a stream to come over this area again. But what you notice is deposition has occurred yet again and created a new layer, layer D, over this erosional surface that was created with B and the missing layer C. So what you see from these diagrams is a 4-step progression of how sedimentary rocks can form from deposition underwater. Uplifting can create the layers to come out of the water. We then have erosion, which may wipe away or change that surface that's now exposed to the air and to the other weathering agents and erosional agents that take the layers away or change the shape of the landscape. And then we see number 4 coming, a new deposition coming in with water. Now again, submerging those layers and creating a new rock layer on the top. So the unconformity is the buried erosional surface between B and D. And as you've noticed, it is represented by a wavy line or a curved line. It's not a straight flat line, and that's the biggest indicator that erosion or an unconformity has occurred. So let's look at these pictures again and let's try to answer these questions. In diagram 2, a new bottom layer emerged due to uplift. What is the most likely classification of this rock? Igneous. Igneous rock, if we go back to the picture before, we see that this new bottom rock layer all along here has those little lines, and if we go to our reference table, we see that that symbol is an igneous rock. It's actually basalt rock. Okay, so we have an igneous rock that's in that new layer. In diagram 3, which layer is missing? We said it was layer C, and it's due to an unconformity or erosion. The top of layer B is now an erosional surface, or an unconformity. In diagram 4, what is the name of the rock which forms layer D? Limestone. That is also something that you can use your reference table for. By what process did this form? From chemical precipitation of calcite. Again, you are not required to memorize that, but if you go to your reference table sedimentary rock chart, you will look for limestone and see that it was formed from this chemical precipitation of calcite. It's directly from the reference table. In diagram 4, what do we call the surface which is in between layers B and D? An erosional surface, or an unconformity. Now, if you don't have this printed out in an outline form from the Edmodo folder, you're going to need to go back and write these questions in our next screencast. We're going to look at other ways we can tell the order of events that this has occurred and that help us determine the age of the geological history. Hope you have a great day. See you next time.